Namaste students. In the last class we were studying about continuity and discontinuity. So we have understood how to check whether the given set of functions are given, how to check whether they are continuous at given points or discontinuous at the given points. So today we continue with the problems connected to continuity. So it is given, examine the continuity of the function. Examine the continuity of the function f of x is equal to sin x minus cos x if x is not equal to 0 and minus 1 if x is equal to 0, and we have to check for continuity. So it is given at x is equal to 0. What is given? F of x is given as minus 1 at x is equal to 0. F of x is directly given as minus 1. Let us take, it is given x not equal to 0, which implies x greater than 0 or x less than 0. What do you mean by that? Left hand limit and the right hand limit are same. So left hand limit and right hand limit are same when x is not equal to 0. So I directly consider limit as x tends to 0 f of x. Limit as x tends to 0 f of x. X tends to 0 means x not equal to 0. I take it as sin x minus cos x. So apply the limits now. It is sin 0 minus cos 0. Sin 0 is 0, cos 0 is 1. So it is minus 1. So what you can conclude from this? Limit as x tends to 0, f of x is equal to, what is minus 1? Minus 1 is nothing but f of 0. If you put x as 0, it will be, say, f of 0. So limit as x tends to 0, f of x is nothing but f of 0, because f of x is minus 1, constant function. Even if you put x as 0, it remains as minus 1. So I conclude f is continuous at x is equal to 0. I think you have understood this problem. Very simple and easy to understand. Please look at the problem carefully. At x is equal to 0, f of x is minus 1. F of 0 will be minus 1. And when x is not equal to 0, it clearly implies x is greater than 0 or x is less than 0. Left hand limit and right hand limits are same. So when we take limit as x tends to 0, f of x, limit as x tends to 0, sin x minus cos x, apply the limits. Sin 0 minus cos 0, sin 0 is 0, whereas cos 0 is minus 1. Hence it is minus 1. Limit as x tends to 0, f of x will be equal to f of 0. Hence we conclude f is said to be continuous at x is equal to 0. That's what it is given. Next problem we need to consider. It is given, discuss the continuity or find all the points of discontinuity of the function. F of x is equal to sin x divided by x for x less than 0, and it is given x plus 1 if x is greater than or equal to 0. We need to test the points of discontinuity of this function. Very simple. See, it can be easily solved like this. I take a left hand limit now. Limit as x tends to 0 minus f of x. Limit as x tends to 0 minus, it is less than 0. Which is the function defined for less than 0? It is sin x by x. What is the limit as x tends to 0, sin x by x? It is a standard formula. Answer is equal to 1. Let us take right hand limit. Limit as x tends to 0 plus f of x. 0 plus. Limit as x tends to 0 plus, which is the function defined for 0 plus, greater than 0. For greater than 0, function defined is x plus 1. If you apply the limit 0 plus 1, it is equal to 1. Now I take at x is equal to 0. What is f of x? F of x will be nothing but x plus 1. I conclude f of 0 is 0 plus 1, which is equal to 1. What is your conclusion now? I conclude limit as x tends to 0 minus f of x is equal to limit as x tends to 0 plus f of x is equal to f of 0. So left hand limit is 1, right hand limit is 1. At x is equal to 0, f of 0 we have got 1. So I conclude f is continuous at x is equal to 0. So I conclude that it is not, there is no point of discontinuity there. Okay, there is no point of discontinuity. I think you have understood this problem. Very simple and equally important. We'll move on to the next question now. Next problem, discuss the continuity or find all the points of discontinuity. That is the question it is asked. Find all the points of discontinuity. Is given f of x is equal to x squared into sine 1 by x. This is for x not equal to 0, and 0 if x is equal to 0 is a continuous function. We need to check whether it is said to be continuous. That's what the important question is. Now, what do you mean by this? X not equal to 0 implies x greater than 0 or x less than 0. So I rightly take limit as x tends to 0, f of x is equal to limit as x tends to 0, f of x. Which is the function defined for x not equal to 0? It is x squared into sine 1 by x. X squared into sine 1 by x. Apply the limits, 0 squared into sine 1 by x. You cannot directly take 0. Sine 1 by 0, it is not like that. It is sine of a value. You know, sine of a value, sine of an angle is always a finite quantity. You know that? Sine of any angle is a finite quantity between minus 1 and plus 1. Even in cos, in case of cos, so it is a finite value between minus 1 and plus 1. So sine 1 by x is a finite quantity. I write it as finite quantity. 0 into finite quantity is 0. This is very crucial step. So substitute the limits. X tends to 0, 0 square into sine of finite quantity. Sine of finite quantity, sine of an angle is always a finite quantity between minus 1 to plus 1. Hence we write 0 square into finite quantity, it is 0. And then at x is equal to 0, f of x is equal to 0, f of 0 is equal to 0. So it is given. So I conclude limit as x tends to 0, f of x is equal to f of 0, f is continuous at x is equal to 0. This is what the problem is. I think you have understood. X squared into sine 1 by x is given for x not equal to 0 and 0 for x is equal to 0. So please understand this step. When x is not equal to 0, it means to say x is greater than 0 or x is less than 0. That means left hand limit and right hand limits are same. Limit as x tends to 0, f of x is x squared into sine 1 by x. Here comes the important step. Substitute the limit 0 squared into sine 1 by x. So whatever the value may be, you cannot say that sine 1 by 0, sine infinity, it is not like. Sine of an angle. Sine of an angle is always a finite quantity. Its value always lies between minus 1 to plus 1. So I write 0 squared into finite quantity, it is equal to 0. At x is equal to 0, f of x is 0. Even if you put x as 0, it is 0. Limit as x tends to 0, f of x will be equal to f of 0. Hence we conclude that f is continuous at x is equal to 0. This is about the way in which we have to solve the problem. We move on to the next problem. Find a relationship between a and b so that the function f defined by f of x is equal to ax plus ax plus 1 If x less than or equal to 3, bx plus 3, if x greater than 3 is continuous, is a continuous function, is continuous at x is equal to 3 is given. So this is what the question is. You have to find a relationship between a and b. Given f of x is equal to ax plus 1 for x less than or equal to 3, and it is bx plus 3 when x is greater than 3. It is given it is continuous. We write f of x is continuous at x is equal to 3. Therefore, we clearly say that left hand limit should be equal to right hand limit. What is left hand limit? Limit as x tends to 3 minus f of x is equal to limit as x tends to 3 plus f of x. This is what the condition is. Limit as x tends to 3 minus f of x. What is 3 minus? Less than 3? It is ax plus 1. Limit as x tends to 3 plus. For 3 plus, which function is defined greater than 3? It is bx plus 3. Apply the limits now. A into 3 plus 1, b into 3 plus 3. We will be getting 3a plus 1 is equal to 3b plus 3. I write it as 3a minus 3b is equal to 3 minus 1. 3a minus 3b is equal to 2. This is the relationship between a and b, so that the given function is said to be continuous. Just consider that left hand limit should be equal to right hand limit. When left hand limit is equal to right hand limit, limit as x tends to 3 minus f of x will be equal to limit as x tends to 3 plus f of x. Limit as x tends to 3 minus means less than 3, it is ax plus 1. 3 plus greater than 3, it should be 3bx plus 3. So a into 3 plus 1 is equal to b into 3 plus 3. 3a plus 1 is 3b plus 3. 3a minus 3b is 2. So that is the relationship between a and b, so that the given function is said to be continuous. I think you have understood this problem. Next, for what values of lambda, it is given, for what values of lambda is the function defined by f of x is equal to lambda into x squared minus 2x if x is less than or equal to 0, 4x plus 1 if x is greater than 0 is continuous at x is equal to 0. What about continuity? What about continuity at x is equal to 1 is given. What about continuity at x is equal to 1? See here, this is what the condition given. You need to find out for what values of lambda is the function defined by f of x is equal to lambda into x squared minus 2x if x less than or equal to 0, and 4x plus 1 if x is greater than 0 is continuous at x is equal to 0. That is the first part. Next, we need to check what about the continuity at x is equal to 1. We need to test the continuity at x is equal to 1. So, let us consider at x is equal to 0 first. Let us consider at x is equal to 0. What is f of x? F of x will be lambda into x squared minus 2x. Put x as 0. F of 0 lambda into 0 squared minus 2 into 0. F of 0 will be equal to 0. F of 0 will be equal to 0. Now, let us take the right hand limit. What is right hand limit? limit as x tends to 0 plus f of x, limit as x tends to 0 plus greater than 0, which is the function defined for greater than 0. So for greater than 0, the function defined is 4x plus 1. So what happens now? 4 into 0 plus 1 means it is 1. Now we conclude that right hand limit is not equal to f of 0, because f of 0 is 0, right hand limit is 1. So it is not continuous, so there is no value of lambda. What is your conclusion? There is no value of lambda as it is not continuous. So it is second part. What about the continuity at x is equal to 1? I write at x is equal to 1. At x is equal to 1. What is f of x? At x is equal to 1. Greater than 0 means at x is equal to 1 means you can take the values. It is given greater than 0. Greater than 0 means it may be 1, 2, 3, anything. So f of x should be taken as 4x plus 1. What is f of 1? It is 4 into 1 plus 1, which is equal to 5. I take limit as x tends to 1. There is no left hand limit or right hand limit here, because it's greater than 0 means common function it is. Limit as x tends to 1, f of x. Limit as x tends to 1, f of x. What is f of x? F of x is also 4x plus 1. So we get 4 into 1 plus 1, we get 4 plus 1, 5. So here we conclude that limit as x tends to 1, f of x is equal to f of 1, that's equal to 5. So f is continuous at x is equal to 1. Since f of x is continuous at x is equal to 1, so what should be the value of lambda? Lambda may be any value. For any value of lambda, for any value of lambda, f is continuous at x is equal to 1. I think you have understood this. So here there is no value of lambda as it is not continuous in the first case. So for no value of lambda, f is, we have to conclude, for no value of lambda, f is continuous at x is equal to 0. Here for any value of lambda, f is continuous at x is equal to 1. Please understand how to solve this problem. It is given at x is equal to 0, f of x is lambda into x squared minus 2x. If we substitute, f of 0 will be 0. If you take the right hand limit, x tends to 0 plus f of x, 0 plus 4x plus 1. If you apply the limits, you get 1. Right hand limit is not equal to f of 0. So we conclude that there is no value of lambda for which f is continuous at x is equal to 0. Suppose if you take x is equal to 1, but for x is equal to 1 it is not given, but it is given for x greater than 0. For x greater than 0 means we can take for 1 also 4x plus 1, it is 5. X tends to 1, generally if we take limits, it is also equal to 5. So limit as x tends to 1, f of x will be f of 1. So f is said to be continuous at x is equal to 1. So I think you have understood how to solve this problem, determining the value of lambda. Take down the next problem. These are very important problems. So find the value of k. It is given. One problem will be definitely asked for 4 marks from this particular part. You need to concentrate on these problems because one problem will be definitely asked from this particular part. So concentrate on these problems. So let us solve it one by one. So you have to concentrate and solve each of the problems. It is given, find the value of k. Find the value of k is given. Find the value of k. So that the function f is continuous at the indicated points. It is given. Let us consider f of x is equal to kx square if x is less than or equal to 2. 3 if x is greater than 2 at x is equal to 2. You have to find the value of k. if the given function is continuous, it is given that this function is continuous, you need to find out whether this is find the value of k. It is given that it is continuous. So what is given? F is continuous at x is equal to 2. So when such is the case, left hand limit should be equal to right hand limit. So what happens now? Limit as x tends to 2 minus f of x is equal to limit as x tends to 2 plus f of x. 2 minus and 2 plus. Limit as x tends to 2 minus less than 2, it is k into x square. Limit as x tends to 2 plus. 2 plus means greater than 2. Greater than 2, it is nothing but 3. Apply k into 2 squared is equal to 3 RHS. So k into 4 is equal to 3. What is the value of k? Value of k is equal to 3 by 4. Hence we conclude that, so if the given function f of x is continuous, if the function f of x is continuous, then the value of k should be equal to 3 by 4. So please understand the problem. Find the value of k if the function f of x is equal to kx square, if x is less than or equal to 2, 3 if x greater than 2 is continuous at x is equal to 2. They have given that it is continuous. Since f is continuous at x is equal to 2, left hand limit should be equal to right hand limit. So left hand limit is limit as x tends to 2 minus f of x. Right hand limit is limit as x tends to 2 plus f of x. Limit as x tends to 2 minus f of x. For less than 2, kx squared is given. For greater than 2, 3 is given. K into 2 squared is equal to 3. 4k is 3. K value is equal to 3 by 4. For k is equal to 3 by 4, the function f of x is said to be continuous at x is equal to 2. I think you have understood this problem. Let's move on to the another question of the same type. You need to test the continuity. So it is given f of x is equal to kx plus 1 if x is less than or equal to 5, 3x minus 5 if x is greater than 5 is continuous at x is equal to 5. Find k. So same type problem. Find the value of k if the function f of x is continuous at x is equal to 5. So probably you can solve this problem, I believe. So what is the first step? F is continuous at x is equal to 5, it is given. When it is given as continuous, I take left hand limit is equal to right hand limit. What is the left hand limit? Limit as x tends to 5 minus f of x is equal to limit as x tends to 5 plus f of x. 5 minus is equal to 5 plus. So what happens now? Limit as x tends to 5 minus less than 5. Less than 5 is kx plus 1. Limit as x tends to 5 plus is greater than 5. For greater than 5 it is 3x minus 1. I think you have understood how we have solved this. So apply the limits now. K into 5 plus 1, 3 into 5 minus 5. 5k plus 1 is equal to 15 minus 5. 5k plus 1 is equal to, it is 10. 5k is equal to 10 minus 1. 5k is equal to 9. K is equal to 9 by 1. So value of k is 9 by 5 if the function is continuous at x is equal to 5. You have understood. It is given f of x is equal to kx plus 1 for x less than or equal to 5. 3x minus 5 for x greater than 5 is continuous at x is equal to 5. They have given that it is continuous at x is equal to 5. They have to find the value of k. Since they have given f is continuous at x is equal to 5, we conclude that LHL should be equal to RHL. That is, left hand limit should be equal to right hand limit. So which is left hand limit? Limit as extends to 5 minus f of x is left hand limit. Limit as extends to 5 plus f of x is the right hand limit. So identify the function defined for less than 5. It is kx plus 1. For greater than 5, it is 3x minus 5. So k into 5 plus 1 is equal to 3 into 5 minus 5. 5k plus 1 is 15 minus 5. 15 minus 5 is 10. Take 1 to RHS, it is 9. Value of k will be equal to 9 by 5. For k is equal to 9 by 5, the given function is said to be continuous at x is equal to 5. I think you have understood this particular problem. I move on to the next one. If f of x is equal to kx plus 1, if x is less than or equal to pi cos x, if x is greater than pi, is continuous at x is equal to pi, find the value of k. We need to find the value of k. Again, the same type of problem. What is given? F is continuous at x is equal to pi. This is what given. It is given that f is continuous at x is equal to pi. So I write, since it is continuous at x is equal to pi, right hand limit should be equal to left hand limit. Left hand limit is limit as extends to 1 pi minus less than pi. What is less than pi? It is kx plus 1. Limit as extends to right hand limit is pi plus. Which is the function defined for greater than pi? It is cos x. So I write it as k into pi plus 1 is equal to cos pi, because pi plus cos x. Cos x you put x is equal to pi cos pi. K pi plus 1 is equal to, what is cos pi? Minus 1. So k pi is equal to minus 1 minus 1. K pi will be equal to minus 2. What is k? K is minus 2 by pi. So for k is equal to minus 2 by pi, so we conclude that the function is said to be continuous. So that's a simple answer. What is given? F of x is continuous at x is equal to pi. So if f of x is continuous at x is equal to pi, we need to find the value of k. So left hand limit should be equal to right hand limit. Limit as extends to pi minus kx plus 1. Limit as extends to pi plus cos x. So what happens when you take x is equal to pi here? K into pi plus 1. RHS, it is cos pi. What is the value of cos pi? It is minus 1. K pi plus 1 is equal to minus 1. Take 1 to RHS, it becomes minus 1. K pi will be minus 2. K pi will be equal to minus 2. And K will be minus 2 by pi. So for x is equal to minus 2 by pi, f of x is said to be continuous at x is equal to pi. I think you have understood this problem. Write down the problem, analyze the problem, and then you can start doing it. It's very simple, very easy to understand. So please try to solve these type of problems. As I have already told, finding the value of k when the given function is said to be continuous is a sure shot problem in the examination. If you refer previous year papers, many times you can see that these type of problems have been asked for 4 marks in part E section. One question will be there, that is 49A, and 50A will be 6 marks questions. Either 49B or 50B will be a question on continuity. So if you concentrate on these type of problems, so you should know the definition of continuity and discontinuity. Remember, a function is said to be continuous, its limit as extends to a, f of x is equal to f of a. Function is said to be discontinuous if left hand limit is not equal to right hand limit first, and even if left hand limit is equal to right hand limit, if it is not equal to f of a, then it is said to be discontinuous at x is equal to a. So in this class we have solved many problems of many problems of that type, and then in particular we have solved problems on finding the value of k when the given function is said to be continuous. So in the next class we are going to solve few more problems on finding the value of k or a and b, etc., and then we test the continuity of the polynomial functions and also composite functions. So in the next class we are going to solve more problems on this type. So that's all for the day. Thank you.